Unit 2C, Lesson 1, Building Functions. In this lesson, we're going to look at different situations, different story problems. Given the information, we're going to create equations to model those different situations. The first problem, last weekend, Emma sold lemonade at a yard sale. The function P of C equals 0.50C minus 9.96 represented the profit P of C Emma earned selling C cups of lemonade. Sales were strong, so she raised the price from this weekend by 25 cents per cup. Which function represents her profit for this weekend? So in this problem, we have two variables we need to look at. We have C, which represents the number of cups of lemonade she sold, and then we have P of C, which represents the profit she earned based on the number of cups she sold. The only thing that's going to change from the previous week is the cost per cup. So in the first week, it was 50 cents per cup. It increased by 25 cents per cup. So 50 plus 25 is going to be 75 cents per cup. So the correct choice is going to be equation 4. P of C is equal to 0.75C minus 9.96. To the next example. Jim is a furniture salesman. His weekly pay is $300 plus 3.5% of his total sales for the week. Jim sells X dollars worth of furniture during the week. Write a function P of X which can be used to determine his pay for the week. Use this function to determine Jim's pay to the nearest cent for a week when his sales total is $8,250. So we know we're going to have a function P of X which represents Jim's pay for that week. We need to determine a y-intercept and a slope. Okay, so the key part we can look at here is he makes 3.5% of his total sales. When we see that word of, that means multiply. So that indicates to me we have a percent, we have a rate multiplied by his sales, which is the variable in this case. So we have 3.5%, we have to convert that to a decimal, so it's 0.035 times X, which represents the total amount of his sales for that week, and then we add to that his $300, and that's like his flat fee. Even if he didn't sell any items, any furniture items for that week, he would still get that base salary of $300. So here's our basic equation. Now we want to go through and find how much money he would make if he sold $8,250 worth of furniture in that week. Once you plug $8,250 in for X into the equation and simplify, you determine that Jim's pay for the week was $588.75. Example 3. Jackson is starting an exercise program. The first day he will spend 30 minutes on a treadmill. He will increase his time on the treadmill by 2 minutes each day. Write an equation for T of D, the time in minutes on the treadmill on day D. Find T of 6, the minutes he will spend on the treadmill on day 6. So we know we need to identify the y-intercept and the slope. So the key word I'm looking for in this case is when it says each day. When it says each day, that's referring to a rate. So the 2 minutes each day is my rate, which represents the slope. That means that 30 minutes must be my y-intercept. There's two different ways we can write this function. We can write it as T of D equal to 2 times the quantity of D minus 1 plus 30 for values of D greater than or equal to 1. Or you can write it as T of D equal to 2D plus 30 for values of D greater than or equal to 0. The reason why this one is a little bit confusing is with the phrasing. In the second sentence, the first day he will spend 30 minutes on a treadmill. Well, the first day, is that referring to day 0, the initial day, or is that referring to day 1, the first day? Okay, so there's a couple different ways you can think about that problem. If you looked at the second equation, the one at the bottom, if we were thinking as the first day as day 1, if I would plug 1 in for D, I would get 2 times 1, which is 2, 2 plus 30 is 32, so that's saying the first day he would have gone for 32 minutes, which we know is false. So that's why for the second equation, we have to represent the first day as the initial day, which would be day 0. To avoid that, if we just want to start with day 1, the first day, that's why we have this notation here, where we have d minus 1. Now if I plug in 1, 1 minus 1 is 0, 0 times 2 is 0, 0 plus 30, then I end up with 30 for that first day. So depending on how you interpret that phrasing, the first day, as day 0 or day 1, that's going to impact how you write that function. To end class, we're going to go through a couple problems that we went through earlier in the year when talking about exponential growth and decay. So Crystal was given $3,000 when she turned 2 years old. Her parents invested it at 2% interest rate compounded annually. No deposits or withdrawals were made. Which expression can be used to determine how much money Crystal had in the account when she turned 18? First, we need to recall our formulas for exponential growth and decay. So the first one, a equals p times 1 plus r raised to the t power. This is our basic exponential growth model. We have our interest rate. It's compounded annually once per year. So that's the first one we're going to use. The second equation would be if we were compounded multiple times per year, which is what the value of k represents, whether that be quarterly or monthly, so on. The third one is if our interest is compounded continuously. So this is when we have to use that constant e, which is approximately 2.71. Then we use that formula. The last one is our exponential decay model. If we're talking about a computer, its value depreciating, going down over the course of several years. So in this case, we're compounded annually, so we have to use this first equation. P represents the principal amount, R represents our interest rate converted to a decimal, and then T represents the number of years. So we know our principal amount is 3,000, which all of these equations have. We're going to be adding, so that narrows it down to equations 1 or 3. And our rate is 0.02. If we move 2%, 2 decimal places, 0.02. So the only difference in equation 1 and equation 3 is our exponent, number of years. In this problem, many students would get it wrong because they see this 18, so they think this 18 must be in the equation somewhere. Well, that's not true. She was given this account when she was 2 years old. She wants to determine how much is going to be in the account when she's 18. So 18 minus 2, that money is only in the account for 16 years. So that's why it has to be equation 1. Now to the last example. A car depreciates at a rate of 4.5% annually. Greg purchased a car for $12,500. Which equation can be used to determine the value of the car V after 5 years? So I want you to go through and think about which of these 4 equations would best model the value of the car after any given number of years.